Good day, everyone. We are a 5-member group of DSECE 1-1, and we are here to explain the concepts of the topics, which are: first, Kirchhoff's rule; second, electromagnetic waves; and third is Faraday's law. For the first topic, Kirchhoff's rule, named after its inventor, Gustav Kirchhoff, which is a rule in analyzing any circuits, be it simple or complex. Kirchhoff's rule consists of two rules. The first rule, which is the junction rule, and the second rule, which is the loop rule. Kirchhoff's first rule, the junction rule, applies to the charge that is entering and will be leaving the junctions. Just to add, a junction or node is a connection of 3 or more wires.
Current is the flow of charge, and the charge is then conserved, meaning whatever charge flows into the junction must flow out. And in Kirchhoff's second rule, the loop rule, applies to potential differences. It is stated in terms of potential V rather than potential energy, but the two are related since U is equal to QV. In a closed loop, whatever kind of energy is supplied by a voltage source, the energy must be transferred into the other forms by the devices in the loop, for the reason that there are no other ways in which the energy can be transferred into or out of the circuit. It also states that the algebraic sum of potential differences, including the voltage being supplied by the sources of voltage and elements that it resists, in any loop should be equal to 0.
Next is the second topic, electromagnetic waves. Electromagnetic waves, or EM waves for short, are waves that are created as a product of vibrations between an electric field and a magnetic field. It is composed of oscillating magnetic and electric fields. All electromagnetic waves travel across space at the speed of light, which is about 300 million meters per second, or 3.0 times 10 raised to 8 meter per second. They are capable of showing interference or diffraction, even though they are not deflected by both electric field and magnetic field. An EM wave can travel through anything: air, solid material, or vacuum, simply anything. They do not need a medium to propagate or to travel from one place to another.
They are transverse waves, so they are measured through their amplitude, the height, and the wavelength, or the distance between the highest or lowest points of two consecutive waves. And for the last topic, which is Faraday's law. Faraday's law of induction, also known as Faraday's law. This law of electromagnetism that predicts how a magnetic field will interact with an electric circuit to produce electromotive force, or EMF, which is a phenomenon that is known as electromagnetic induction. It is a fundamental operating principle of transformers, inductors, and many types of electrical motors, generators, and solenoids.
It also describes how an electric current produces a magnetic field, and how the change in magnetic field generates an electric current in a conductor. Adding to this, Faraday's experiments showed that the EMF induced by a change in magnetic flux only depends on a few factors. First is EMF is proportional directly to the change in flux. Second is that it is at its greatest when a change in time is smallest. EMF is proportional inversely to change in time. And lastly, if a coil N turns, an EMF produced will be N times greater than of a single coil, so that EMF is proportional directly to N. Thanks for watching!